Okay, Mick, I'm going to do a quick walkthrough here of the code we did yesterday, along with a few suggestions. The first one is I want to suggest that you try to upgrade your version of R to the most the latest version, which is 4.0.4. We're going to look for R language download. Come over here, download R. All right, oops. Download R here. Now you see it's going to say Mac OS X. This is you. Click on that. Now, first of all, I don't actually have a Mac, but I think I have a pretty good idea how it actually works, okay? So here's your package, all right? Okay, so you want to download this. Then you want to probably double click on the file menu to run the install process, okay? Now, and then you want to restart Rstudio. I trust that you are in fact using Rstudio, right? So then what you want to do is you want to come over, open up your file manager, and look for this, and then look for the file, and then double click on it, and it should give you the option to install it on Mac OS. I am guessing. Okay, you may need to run it as administrator. If that's the case, that's a different question. Okay, um, or it may just prompt you for a password or something. But you really be better off if you can update to 0.4.0.4. Okay, so now we got that installed. The next thing I want to suggest you do is create a top level directory for all your R code. Okay, you see it now. I'm not sure what the directory structure. Now, in your case, it'll probably be in the home folder. Okay, so if we say documents is my top level directory or my R folder. Okay, then what I want you to do is come down, create a directory. I created one called R. Okay, but you may want to use the name of your class, Stats 101 or something like that. And this is your top little R code directory. Then you use a separate directory for each one of your projects for your class, okay? And you give this file here a meaningful name, all right? But the way you do this is click on Rstudio, click on this, click on New Project, click on click on New Directory, New Project. Now I'm going to create a stats one. Now you can see here, this new directory is going to be a subdirectory or a folder underneath my R directory. Okay. Okay. So now I got a top level directory called stats. Okay. And this way, and I would put all my code in my data underneath this directory for that class. Okay. So now that we have a top level directory, let's switch back to the previous directory that we were using before. Okay. Oh, the other thing I want to encourage you to do every single day when you first turn on the R language, go to Packages, click Update. So what you want to do is you want to click Select All, okay, and then Update. Okay, and you want to update any packages that shows up there. Now, if while you're updating a package, it asks you, do you want to install from source? The answer to that question is yes, always. Okay. Always also watch for any possible error messages over here. Your screen may be a little different than mine. All right. Remember, this is the project directory I created yesterday. Now you go click on the you go click on the file. It says capital R PROJ. That'll open up that project. Now, the one thing about using project directories, because the code and the data is in the same position, okay, you don't have to worry about uh, you don't have to worry about paths. Okay, and you see this. Now here's let's see here. Now and here is all the directories. Here's the package you have to make sure to install. It's ggplot2, dplyr, r markdown, and flex table. And the way I want you to install the package is by using the package menu. Okay, so you go. The first thing I'll point out, so in the console, when you see mine says R version 4.04, when you update your Mac OS R version, yours should say R.0.4 also. Okay. The way I want you to install these packages, go to the package menu, then use install. Then do ggplot2, okay? Click install and do that for dplyr, r markdown, and flex table 2. And also scales. All right? So those are now we got our packages installed, okay? Well, we're not actually going to use scales in this particular project. Just let's get rid of that. Okay, so like I said, remember, you only have to install these once, okay? You only have to install them once, but you want to try to run an update every single day, all right? Now the simple library function ggplot2, dplyr, anytime, and flex table. Now, what you see here is this is the hashtag defines the size of the heading. You want to come over here, of course, and change this first level heading to something that has to do with you. One thing you want to do is you may want to change this title here, okay? All right, to something that's going to be recognized. But see, this is going to create a second level header. All right. So let's do it. Let's just do this. Let's just create a sample header here, okay? Header 1, header 2, and this will show us exactly 3, 4. Oh, no, I almost forgot. The way you start out to create a new R Markdown file is you do this. You go click on this menu here or the file menu, click on R Markdown. Now you go into the title for the program and your name here. Now I want you to notice you got 3 different formats: HTML, PDF, and Word document. You want to select the one you want to use. In our case, we're using PDF because I think that's what your instructor requested. Okay, header 4. Okay, 4. You can also use bulleted text. All right. You can also type plain text. Okay. And one note is when you do these headers, as you see down here, you have to have a space before and after the header lines. Okay. So now we got the 3 types of headers. We got bulleted text and we got plain text. The first, and these next, what you see is these things called here. They're called code chunks. And you can see this contains a small section of code. And you click the arrow button over here to actually run this piece of code only. And using this arrow is a good way to troubleshoot code. Okay, you can narrow it down to the chunk problem. This is the README file here that you gave me. All right. And the problem with the README file was the quotes. Okay. It was the quotes. So what I did is, okay, is I removed all the quotes from all the text. All right. And then I removed the spaces between the words. Because before this was U note 12. Well, I removed all the spaces. Okay. The trouble is if you have a space up here, say something like that, I may try to interpret this as two different columns. And that was part of what your trouble was. The problem was your was the quotes around your text. Okay. So now we can run this. All this says is uh, read the file. The dot slash says look for the file in the current working directory. Now we're going to use what's called a dplyr command. Okay, filter. We're going to create a new data frame that only contains these three branch IDs here, which is what your paper said, right? So we're going to take the current data frame. We're going to pipe it or send it through here, through the filter command. Then we're going to use it. Then we're going to do a filter to you can think as the double quotes means the branch ID of 1742. The bar means or. So we want a branch ID that contains 1742 or 47 or 5181. Okay. Now we're going to take the date field and use the as.date function to convert it to a date field. Now we're going to do a simple structure command to see exactly what the code looks like. Okay. Then we're going to summary command on sales. So let's run this. Let's come back up here. Run the first chunk for the libraries. Now let's run the second chunk. Okay. You can see up here, this describes the different fields: branch ID, date, product, and sales, integer, date, character, and integer. Now, the next thing here, this is a summary of the sales field. And it says the lowest number of sales was 1, or lowest quantity sold was 1. The highest quantity sold was 99, and the average number of quantity, or the mean, was 50.83. Now, total quantity of phones. What your instructor's looking at, to me, was the total quantity of phones sold. Okay, for phones sold for each phone. So we're going to create a new data frame called sales. Again, the df current. We're going to pipe that through a command called select. The select command is very much like dplyr, which we're using here, is very much like SQL. You got a select statement. So this means we're only going to use the product and the sales columns. Let me mention right here is that when you look at a column in R, it could be called a column, it could be called a variable, or it could be called a feature. All three mean the same thing. So we're using the column product and the column sales. Now we're going to group by or count by or total by the product type. Okay. Summarize says run this command here. We're going to create a new feature and summarize a new variable, new column called total, which is some command means just what it says, and it's total the sales by product. Okay, totals the sale by product. Now we're going to use the flex table command, which you did up there, and we're going to create a really nice looking. I'll just mention. Well, actually, the double colon means use function. So this is the package. So we're saying use the flex table function in the flex table package. Now, because we installed flex table up here, okay, we don't actually need this first column here. But the thing is, you could call this function without loading the library back up here, okay? And the reason you might do that is simply memory. Okay, you may not have this machine with a lot of memory in it, so you only want to call the functions which you actually need to use, rather than the whole package. Okay, so let's take a look at this table now. So here's the total for the 3 different phones. That means the most phone, the U Note 12 sold 2,278 total units. Phones were sold, and so forth. Okay, very simple plot. Now, sales by branch in phones. This is a little more tricky now. We're creating a new table called branch. Okay, again, piping the df into the group by function. Again, this time we're using product and branch ID. And once again, we're going to summarize, create a summary field called sales using it here. But as you'll see, we have, you know what, let's try, what we're going to do is, shoot, I'm going to try doing this by branch ID. Let's try this now. Okay, so what you see now, you got a table, and it's sorted to total by branch and by phone. Okay. Now, so now you got your table. This is the branch ID, it's the phone type, and it's the total for that branch. Here's the second branch. Here's the total for each one of the phones. Here's the third branch and the total for each phone. Okay. So now we got a nice table there that shows us how to do this. That gives us hopefully what your instructor was looking for. Now, sales for branch 1587 for the Milky S20 phone. Once again, the filter section, we're creating a new thing called Milky Sales. Using the filter command, we're going to pull out the rows or records that contains a branch ID of 5181 and a product ID of Milky S20. And then we're going to plot that. Okay, look at the plot command. ggplot2 is a command. This is the data table we created up here. Geom is the type of plots you want to use. Okay, now, if you come over here now and you do this, geom underscore, this will give you all the type of plots you want to use. We're using a column plot. Here's a box plot you'll probably run into at some point. The column we're currently using. The histogram you may run into at some point in statistics. A scatter plot is called a point. To create a scatter plot, you use a geom point. Okay, and the beauty of ggplot2 is the syntax is always the same. Call ggplot2 at the data frame, call the type of plot you want to create, then use the AES function. AES, I think, stands for aesthetics. Okay? And then with the AES function, you call the X and the Y variable. As you know, the X variable is almost always a horizontal axis. Okay? And since he mentions the word time, you got to use it. You got to put the date field along the x-axis. That's very common. That's called time series analysis, time series variable. Okay, you go see lots and lots of tables that include dates in. Now the vertical axis is called the y-axis, and this is the variable that we want to plot. So we want to plot the sales quantity, okay, for this branch and for this product. Then labs just says is used to create in labs it's just used to create a label, among other things. Let's do this now. So now what we got the product sold for each month. Okay. Dates across the bottom, right? Quantity up here. Now we could also come up here, for instance, and do X and rename hopefully I smell quantity right. Quantity. Q-U-A-N-T.
Quantity. The amount or number of a material or immaterial thing not usually estimated by spatial measurement.
Q-A-N-I-T-I. Always check my spelling, okay? So now we got quantity sold for this phone, for this branch. And this is just the date sold, okay? You notice all I did within the lab function, I said y equals, and that's how you change the y-axis label. These things here, the 0 to 20, 30, 40, those are called labels. And since it's on the y-axis, this is the y-axis label. So anything you want to do to the y-axis labels, you always look for y labels. This is along here, the x-axis label are months. Okay, so hopefully this will give you a start. And I want to emphasize finally one more thing. This code here, you will use over and over again. This is the basic set of code that you need. Okay. You're going to load some libraries. You're going to read some data. You're going to do some data analysis. You're going to maybe do some data cleaning, okay, or data and rearrange the data in a format that you can use. Then you're going to do some analysis. Okay, you're going to do a summary plot, a summary table right there, and then you're going to do this. You're going to pull out some data and you're going to plot some data. You got to do a data visualization. In this case, we're creating a nice table. And here's the thing: the reason you can use this code because all you got to do is change the name of these fields here, okay, to whatever the new values you want to use them for. Okay. The summary command and this command up here you use all the time. Okay. Let's say, for instance, we looked at sales and it has a negative number in it. Well, you shouldn't, unless everybody, you should never have a negative sales. Okay. One thing you can look, and if you can see you got a negative number in the field, the question you want to ask yourself is, should there be any negative numbers in this field? If the answer is no, then you got a problem with your data. Okay. But anyway, when you do our program, you can do the same thing over and over and over again in many cases. Load libraries, read data, clean data, do some summary stats, and do some plots. Now where the tricky part comes in is the point between here and here. Okay, because you may have to do a lot of data cleaning to fix up the data sets so you can use it yourself. Okay, so hopefully this was both instructional to you and encouraging to you. You're not nearly you're much closer to our programming than you realize you really are. Because if you can understand this code here, again, this will cover 80 to 90% of every code that every R program you will ever write. Simply because you're going to do the same thing over and over again. Okay. Anyway, hope this is helpful. If you have any questions, be sure to just send me a text or something like that. But remember, you need to learn this you need to understand this code just in case your boss asks you. The reason you want to understand this code finally is just because what happens if your professor says, well, what does this select statement mean? You want to be able to give him an answer. Okay. If he says, wait, what package did you use to do this group by? You say, well, that's dplyr and tidyverse. Okay, and so forth. What's this flex? Well, flex table is a package used to create tables. So we create a flex table called cells, you see. And it's that simple to describe this code. All right? Because remember, you're turning the code and the report. So if he comes back and asks you, what does this statement mean? You want to be able to answer his question. All right? Okay, Mick. Hope you did find it helpful and suggestive. And again, learn this code here, and you'll be able to do 80%. You'll be able to do 80% of your projects. Okay. Take care, friend.